Example 10.3 is a very easy 10 mark question. It's been repeated often also. So do not leave this sum. Okay, you're sure to get 10 marks because it's a very easy sum. Okay, let's start with it and try to understand this. They say an urn contains 4 white and 3 red balls. Find the so there is a big basket or urn or a urn and a பெரிய பாத்திரம் மாதிரி இல்லையா? So it has 4 white and 3 red balls. Now find the probability distribution of the number of red balls in 3 draws one by one from the urn. So there are 4 white and 3 red balls in that basket or whatever, and you're given 3 draws, that is 3 times you're going to take a ball from inside. Now what is the probability distribution of the number of red balls that you will get in the 3 draws, right? So if I write the probability of getting a red ball, right? So totally how many balls are there? 7 balls. 4 plus 3, right? In that 7 balls, the probability of me getting a red ball is 3 by 7 because there are only 3 red balls. And the probability of not getting a red ball, that is the probability of getting a white ball, right, is out of 7 balls, the probability of getting a white ball is 4 by 7, right? Because there are only 4 white balls. Good. Now, if you're going to 3 times, if you're going to take a ball, right, what is the probability that it might be a red ball? The values of x can be 0. That is, you cannot get a red ball at all. Maybe you will get only a white ball. Or you could have got 1 red ball. Or you could have got 2 red balls, right? 3 times when you're drawing. Or all the 3 times you could have got a red ball. Okay? So what are the possible outcomes? Either you don't get any red ball in all the 3 chances. You take only white balls. Or you get 1 red ball and then the other 2 chances you get white balls, or you get 2 red balls and in the other chance you get a white ball, or all 3 chances, that is all 3 draws, you get the red balls, right? Good. So we have 3 different data here: probability of getting a red ball, probability of getting a white ball, and what are the possible outcomes. Okay, now with this, what are we supposed to find? We are supposed to find the probability distribution of number of red balls in 3 draws one by one from the urn. First is with replacement. That means I am taking a ball. Once I see that it is not red, I am going to go replace it again. Okay, let's get started with that. So the probability that I'll take first outcome of 0, where x is equal to 0, that is all 3 turns I'm getting only a white ball, right? Probability of white, 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 right? So in the first chance when I got white, right, it was 4 by 7. What is the probability of getting a white ball? 4 by 7. Now second chance also I'm getting only a white ball, and please note that it is with replacement. So when I'm taking the ball, I'm putting the ball back inside, right, after seeing the color. So the number of balls in the denominator always remains the same. So 4 4s are 16, 16 into 4 64, 49 into 7 is going to be 3 4 3, right? Now next, let's see the next outcome. Probability of x is equal to 1. That is, I might get 1 red ball, then 2 whites, or first a white, then a red, and then a white, or probability of getting 2 whites first and then a red. So that 1 red ball that I pick up, it can come in any order. In the first chance I can get a red ball, or in the second chance I can get a red ball, or in the third chance I can get a red ball. So in that case, it is going to be, what is the probability of getting a red ball? 3 by 7. So it is going to be 3 by 7 into 4 by 7 into 4 by 7 plus, so all this we are doing it with a replacement. Please remember that once we take the ball, we see the color, we are putting the ball back into the urn, so the next time we take it, we are always left with a pool of 7 balls. We are always picking only one from 7, right? Similarly, when I'm proceeding again, it will be 4 by 7 into 3 by 7 into 4 by 7 plus 4 by 7 into 4 by 7 into 3 by 7. Very simply put, I can write it as 3 times 3 by 7 into 4 by 7 into 4 by 7. You multiply all of this, 9, 3 3s are 9, 9 4s are 36, and 36 into 4, you must get around 144, right? So it's basically 144 by 343. We already found out 7 into 7 into 7 is 343 from here, right? Now let's check the next outcome. That is, I'm getting 2 red balls. When I get 2 red balls, I can get 2 reds in my first pick, first and second pick, or first a red, then a white, then a red, or a white, a red, and a red, right? So these are the 3 different outcomes that I have. So the probability of getting a red ball is going to be 3 by 7 into 3 by 7 into 4 by 7 plus 3 by 7 into 4 by 7 into 3 by 7 plus 4 by 7 into 3 by 7 into 3 by 7, or simply put, you can write it as 3 times 3 by 7 into 3 by 7 into 4 by 7. So 27 into 4, right? That is basically 36 into 3 is going to be 108 by 343. Denominator remains the same. Now, what is the probability that all are red balls, right? So that's going to be only 1, right? So it's going to be probability of getting all as red balls, which is nothing but 3 by 7 into 3 by 7 into 3 by 7, which is 27 by 343. So these are my different values for the different outcomes. See, it's pretty simple. Just do your multiplication properly. Now this, right, is what we have found out for the different outcomes, but the required thing is we have to write the probability distribution, right? So for that, so the probability distribution, I'm going to put a tabular column here. So this is how the table will be. So probability of x is 0, 1, 2 and 3, right? These were the 4 outcomes which we initially derived, right? So when x is equal to 0, what will be the different values? When x is equal to 1, for whatever answers we got, we are just putting it in the tabular column. And this was 27 by 343, and for 2 it was 108 by 343. That's all, right? So this is a probability mass function, because your sum of all the probability outcomes is going to be equal to 1, and also all your values, right, are greater than or equal to 0. So it satisfies these 2 rules. Now this sum we did it with replacement, right? Now let's see the next part, which is without replacement, right? So for that, I'm going to erase this part. So the probability of getting red balls in 3 draws one by one from the urn without replacement, right? Which means that once I take the ball, right, irrespective of the color, I look at the color of it and I don't put it back into the urn. Okay, I'm going to have it in my hand itself. So first let's write probability of x is equal to 0. That is, I'm not getting any red ball and I'm getting only white balls. So which is going to be probability of one white ball is 4 by 7 into, this is the difference between with and without replacement. Now we are doing without replacement, meaning that I'm not going to put that ball back into the urn. So earlier there were 7 balls from which I picked one, but now I have already taken one, so there are only 6 balls left, right? And even in that 6 I've already taken a white ball, so the number of white balls reduces also, right? Next time also I'm taking the second ball and not putting it back, therefore the number of balls inside becomes 5, and since the third one is also a white ball and I've already taken out 2 white balls, that is going to be only 2 more white balls left in the urn. So this, when you multiply, right, you can cancel this and this would get cancelled, would get 4 by 35. Okay, now let's do the next one. This will be interesting. Probability of x equal to 1. That is probability of getting a red ball in the first time, probability of getting a white, then a red, then a white, or the probability of getting a white and then finally a red ball, right? So this, when we write, it's going to be 3 by 7 into the probability of getting one white ball is 4 by 7, right? I need not reduce this here because I have not yet taken a white ball. So the first time I am taking a white ball, so it becomes 4 by, however, I have taken off one ball from inside, so it becomes 4 by 6. It reduces by 1. Then next also I am getting a white ball. So the number of balls inside becomes 5 because I have already taken 2 balls and I have already taken one white ball. So it would become 3. Okay. Likewise, the same logic applies here. The probability of taking a white ball first is going to be 4 by 7. And the probability of taking a red ball is going to be 3 by 6 because I've already taken one ball. And the probability of taking another white ball is going to be 3 by 5. Right? Likewise, try doing for the third one. Right, so this is nothing but 3 times of 3 by 7 into 4 by 6 into 3 by 5, right? So this is going to be, so eventually you get 3 3s are 9, 2 9s are 18 by 35. So the next outcome would be the probability of getting 2 red balls, which would be either you get a red W or a red W red or W red. So the probability of getting a red ball is going to be 3 by 7 into 2 by 6 because we have already taken one ball. But the white, this is the first time we are taking a white ball, so the probability would be 4 by 5, right? That into same method you apply. this is 2 here. In case it's not clear, I'll write it again. Good. So this becomes 3 times 3 by 7 into 2 by 6 into 4 by 5. So same thing, you cancel everything. You need to get 12 by 35, right? And the last outcome is going to be probability of x equal to 3. That is, in all my chances, I get red, red and red. So which is going to be 3 by 7 into 2 by 6 into 1 by 5. This is because it is without replacement, and the value of this is going to be, get cancelled here, 1 by 35. Okay, now for without replacement, the last step is to put the tabular column, right? So let's quickly put the tabular column. X is going to take value 0, 1, 2 and 3, and this is, so when x is equal to 0, I got 4 by 35. You can refer to this. When x is equal to 0, we got 4 by 35. When x equal to 1, we got 18 by 35. When x equal to 2, we got 12 by 35. X equal to 3, we got 1 by 35. That is what I am writing down here. Likewise, all the, since it's a probability, it's going to be a probability mass function, distribution function, because the sum of all my possible outcomes is going to be equal to 1, right? And all my pi's are greater than or equal to 0. This is just the condition which is satisfied. So it's a very, very easy sum. You can do it very quickly. It is mostly a 10-mark question, not because of the complexity of the sum, but rather, for with and without replacement, the number of steps which is involved, right? So otherwise it's a very easy sum to understand and grab. So don't miss the 10 marks for this.